Nuclear magnetic resonance, or NMR, is a technique used to determine the content, purity, and molecular structure of a chemical sample. The physical phenomenon of NMR uses the fact that certain nuclei are magnetic, allowing them to absorb and then emit very low-frequency electromagnetic radiation, or radio waves. The energy of the specific frequency depends on the magnetic field strength and the magnetic properties of the isotopes of the atoms. The most commonly studied nuclei are hydrogen-1 and carbon-13, although nuclei from isotopes of many other elements, such as hydrogen-2, lithium-6, boron-10, nitrogen-14, oxygen-17, and fluorine-19 can be studied by NMR as well. The NMR that we have in this lab is an EFT 60. This allows users to do rapid collection of one-dimensional and two-dimensional hydrogen-1 and carbon-13 spectra. In general, the solvent used for NMR should not produce signals that will complicate the spectrum of the sample. Since most solvents contain hydrogen atoms, special expensive solvents are used, where the hydrogen atoms have been replaced by deuterium, hydrogen-2, a heavier isotope of hydrogen. Typically, deuterated carbon tetrachloride, or chloroform, are used in our lab for organic samples. For chemicals that do not dissolve with the solvents listed, deuterium oxide or deuterated water is used. This is what a sample looks like when it is dissolved in the solvent in an NMR tube. Cover the NMR tube with a cap, and you label your sample. Wipe the NMR tube with a Kim wipe to remove all fingerprints. Put the spinner on using a Kim wipe and adjust the length. Lift the lid on top of the magnet to reveal the sample compartment. With the lever up, press and hold the eject button and gently insert your NMR sample into the silver tube. Gently release the eject button to lower your sample. Put the lever down to start the sample spinning. Spinning is important to make sure that the entire sample feels the same magnetic field. This is what an NMR spectrum looks like. Normally, we use the MNOVA software to analyze NMR spectrum. The different peaks in the spectrum correspond to different hydrogen atoms in your sample. You will learn more about how to interpret NMR spectra in your organic and spectroscopy courses.